Hello, I am Dr. Ömer Tekince. In this video, I will show you how to perform 3D scaling in EQMatch. In this example, we will load earthquake record pairs consisting of X and Y horizontal components into the software, define a target spectrum, select the record pairs, run the 3D scaling analysis, and evaluate the results using graphs and numerical tables. By the end of this video, you will see how X, Y record pairs are compared with the target spectrum, how the SRSS-based spectral check is performed, how the PES status is evaluated, and how the scaled record pairs can be used in subsequent engineering analysis. In EQMatch, 3D scaling is a pair-based scaling workflow in which two horizontal earthquake components, namely X and Y records, are evaluated together. The term 3D here does not refer to the three-dimensional analysis of a structural model. Instead, it refers to the scaling and evaluation of record pairs consisting of two horizontal components. In this method, each XY record pair is considered together. The goal is to make the combined spectral behavior obtained from the horizontal components compatible with the selected target spectrum. EQMatch uses an SRSS-based spectrum check for this evaluation. SRSS can be understood as the square root of the sum of the squares of the spectral values of the two horizontal components. This approach helps control the spectral demand generated jointly by the X and Y components instead of evaluating the individual horizontal components separately. 3D scaling is especially useful for time history analysis, where two horizontal components will be used together. However, the magnitude of the scale factors, record selection, target spectrum, and control period range should all be evaluated together from an engineering perspective. Now, let us move to the EQMatch interface. First, we check the analysis method in the project settings section. We select scaling as the analysis method and 3D scaling as the scaling mode. Next, we define the control period range over which spectral compatibility will be evaluated. In this example, we will use specific T minimum and T maximum values. In real projects, this range should be selected by considering the fundamental period of the structure, code requirements, and engineering objectives. For this example, we will assume a hypothetical 10-story building with a fundamental natural period of 1 second. For T minimum, we will use 0.2 multiplied by 1 second, which gives 1.2 seconds. For T max, we will use 1.5 multiplied by 1 second, which gives 1.5 seconds. This means that the spectra of the earthquake records in this example will be scaled so that they do not fall below the target spectrum between 0.2 seconds and 1.5 seconds. In the required minimum ratio field, we can enter the minimum ratio that the combined spectrum must satisfy relative to the target spectrum. In this example, we will keep this value as 1. Now we move to the files section. EQMatch can load earthquake acceleration records in AT2, ASC, TXT, or CSV format. One of the most important points in a 3D scaling analysis is that the X and Y horizontal components must be correctly paired. In this example, we will use previously prepared horizontal earthquake records consisting of 5 pairs. After the records are loaded, EQMatch can automatically detect suitable X-Y record pairs. From the file summary section, we can check the number of records, the automatically selectable X-Y pairs, target spectrum information, and the record folder. At this stage, it is important to make sure that the X and Y components belong to the same earthquake record and that they are paired correctly. Incorrectly paired records may lead to engineering misinterpretation of the analysis results. A target spectrum must be defined before performing the 3D scaling analysis. EQMatch supports both a user-supplied target spectrum file and a code-based target spectrum generated within the software. In this example, we will load an external target spectrum in TXT format. While the target spectrum source menu set to import from file, we click the Select Change Target Spectrum button. The selected target spectrum is displayed on the screen as both a numerical table and a graph. Now we move to the record selection section. By clicking the Create Automatic XY Pairs button, the XY pairs can be selected automatically. Now we move to the Run Analysis section. In the pre-analysis summary, we can check the analysis settings one final time. The analysis type should be shown as 3D scaling. The target spectrum should be selected and the number of selected XY record pairs should be correct. If everything is correct, we click the Run Analysis button. At this stage, EQMatch performs the required scaling operations for each XY record pair, generates the scaled records, performs the SRSS-based spectral checks, and prepares the necessary grep and data files for the analysis outputs. When the analysis is complete, the results can be reviewed automatically in the results and graphs section. After the analysis is complete, we move to the results section. At the top of the screen, we can see the scaling status. If the defined control criteria are satisfied, the status is shown as pass. The same section also displays the minimum ratio, mean ratio, maximum ratio, and final scale values. The minimum ratio represents the lowest ratio of the scaled SRSS spectrum to the target spectrum within the selected control period range. The mean ratio helps us evaluate the average spectral compatibility within the control range. The maximum ratio shows the greatest amount by which the scaled spectrum exceeds the target spectrum. The graph displays the target spectrum and the mean scaled SRSS spectrum together. This graph is very useful for quickly evaluating the overall compatibility of the selected record set with the target spectrum. From the tables in the lower section, we can examine the minimum ratio, mean ratio, maximum ratio, and the corresponding period values for each XY record pair. However, checking only the pass status is not sufficient. The magnitude of the scale factors, the distribution of the spectral ratios, and the variability among the record pairs should also be evaluated from an engineering perspective. Now we move to the graphs section. In the graph section, we can inspect the spectrum graphs for each record pair, the mean scaled SRSS spectrum graph, ratio plots, and time history outputs. When we select a response spectrum graph, the X component, Y component, scaled components, target spectrum, and SRSS-based spectra can be displayed on the same graph. This graph allows us to examine the behavior of the selected XY record pair relative to target spectrum in detail. The mean scaled SRSS spectrum graph summarizes the overall spectral behavior of all selected record pairs. In these graphs, we check whether the target spectrum is adequately satisfied within the selected control period range. In addition, the numerical data table on the right side of the screen shows the numerical data associated with the selected graph. The user can export graphs, spectrum data, and numerical tables, or select them for. After 3D scaling, it is not sufficient to review only the spectra. The scaled time history records should also be checked. In the graph section, we can open the time history graphs for X and Y components. In these graphs, we can compare the original and scaled acceleration, velocity, and displacement time histories. In 3D scaling, the shape of the record in the time domain preserved. The amplitude level changes because of the applied scale factor, but the duration and the overall time domain character of the record are maintained. This review helps us evaluate whether the scaled records are suitable for engineering analysis. At the end of the analysis, EQMatch generates the scaled XY acceleration records, SRSS-based response spectrum data, scale factors, control tables, and graph files. The user can open the output folder directly or prepare the analysis files as a zip package. We can select the graphs that we want to include in the report and click the Add to Report button. Then we move to the reporting section and create the 3D scaling report by clicking the Create PDF Report button. If desired, a report can also be generated in Word or TXT format. The report may include the project and analysis information, selected XY record pairs, the target spectrum, scale factors, SRSS-based spectral check results, graphs, and numerical summaries. In this video, we loaded XY earthquake record pairs into EQMatch, created the target spectrum by importing an external TXT file, ran the 3D scaling analysis, and evaluated the results in the Results and Graphs section. In summary, 3D scaling is a traceable method in which two horizontal earthquake components are evaluated together. It provides an SRSS-based spectral check and helps scale record pairs relative to a target spectrum. To try EQMatch or review the available license options, please visit our website EQMatchsoftware.com. Thank you for watching.